Hello, welcome to the module on algorithms. In one of our earlier modules, we have already discussed on problem definition and concepts of problem solving. Let me give a brief overview of problem definition and problem solving. Problem definition involves describing the problem in a clear and precise statement. That is, we should know exactly what needs to be done. Once we understand the problem, we need to find the input for the problem and the output to be produced. Then we have to describe the process which converts the given input into the required output. That is, we have to identify the logic to solve the problem. There are set of techniques and graphical tools that help in providing logic for solving a problem. They are algorithms, flowcharts and pseudocode. The topics for discussion in this module is algorithms. In brief, an algorithm is a set of step-by-step procedures that provides the correct answer to a particular problem. By following the instructions correctly, you are guaranteed to arrive at a right answer. Let us delve in detail into algorithms. So, algorithm is a problem solving method which consists of sequence of unambiguous instructions to solve a problem. Problem here denotes computational problem, not just any kind of problem. What is a computational problem? Computational problem is a problem whose solution can be implemented using a computer. We will discuss an example for a computational problem. A good example for such a problem is to find the factorial of a given number. The specification of the problem should always include the description of what the input of the problem is going to be and the desired output. Well, you will be given a number and the factorial should be calculated for that number. That is, input is the given number for which the factorial has to be computed and the output is the factorial of the given number. Therefore, if the input is 5, the output will be 5 into 4 into 3 into 2 into 1. Wow, nice. It is 120. Let us see some examples of non-computational problem. How do I convince my teacher to let me inside the class if I am late? What is the cure for some disease, say let it be cancer? These problems cannot be solved by computers. Coming back to the algorithms, the algorithm will give you the logic of the program, that is a step-by-step description of how to arrive at a solution. In general terms, an algorithm will provide you the blueprint for writing a program to solve a particular problem. One question over here, actually why do we need to go for algorithm? Yes, correct. Algorithms are used to achieve software reuse. Well, once we have an idea or blueprint of a solution, we can implement it in any languages such as C, C++, Java and so on. So, do we use algorithm in our daily life? Yes. In fact, let us see. Had a strong filter coffee, I guess. Not only over here, We deploy algorithm in many places in our daily life, such as when we get a call over the phone and so on. Next, we will look into the qualification of an algorithm. In order to qualify as an algorithm, that is, a sequence of instruction must possess certain characteristics. The algorithm should be precise, be unambiguous, be finite, not have even a single instructions repeated infinitely, produce desired output when the algorithm gets terminated. The implementation side of an algorithm is the program. Now, we will look into the control structure used in algorithms. Recall, I have told you that an algorithm consists of finite number of steps, and the steps may consist of decision making or repetition, or it may be executed sequentially. Broadly speaking, an algorithm may employ three control structures, namely sequence, decision or selection, repetition or looping. We will look into one by one. First, let us go through sequence nature of algorithms. 1, 3, 5, 7, 9. This is a sequence. 1, 2, 4, 6, 8, 16. This is also a sequence. Then what is a sequence over here? Sequence means that each step of the algorithm should be executed in a specific order. The coffee preparation shown earlier is an example of sequential control structure. Let us look into an example of addition and average of 3 marks obtained by you. Input for this example problem is that you need 3 marks. For example, A, B and C, which are to be added, and the output to be produced is the sum and the average. Assume added value is stored in sum and average. Now, we are going to write algorithm for it. Let me briefly explain the algorithm. Any algorithm should do 3 things, namely input, process and output. Identify the input and the output for the given problem. Input is the marks scored in 3 subjects, and the output is sum and average of 3 marks. So, what is the process? That is, how do you find the output given the input? Yes, we need to convert the given input into the required output. That is, we need to process the input. Here, the process is to add 3 marks to find the sum and divide the sum by 3 to find the average. Shall we now write the algorithm? See the algorithm over the screen. Here is the algorithm to find sum and average of 3 numbers. Step 1, start. Step 2, read 3 marks, say A, B and C. Step 3, add A, B and C. Store it in sum. Step 4, divide the sum by 3 and store it in average. Step 5, display the sum and average of your 3 marks. Step 6, stop. First and last step of an algorithm is always start and stop. Second step is to read the marks whose sum is to be found out. Then we add 3 marks to find the sum and store it in a variable called sum. This is third step. In fourth step, divide the sum by 3 to find the average and store it in a variable avg. Then we display the sum and average as results in fifth step. Finally, we stop the algorithm. Here, step 2 is for getting the input, step 3, 4 and 5 represent the processing to be done, step 5 is to show the result. In this example, we have used sum and AVG. What are they actually? They are variables. What do you really mean by a variable? A variable is something which can have a varying data. For example, A may hold 95 at some point of time in an algorithm and a different value at some point of time in an algorithm. So, A, B, C, sum and AVG are variables. The values of these variables may change at any point of time in the algorithm. The variables act as placeholders. The above algorithm performs the step in a purely sequential order. What's up? Yeah, the next is decision making structure. Shall we bunk class today? Answer is almost yes, but at least a few no, I guess. In the above question, you all know that you have to deploy your decision. In coffee preparation, if you need milk to be added or not, that depends on your taste. There also you have to deploy your decision. See the algorithm for this problem of preparing black coffee or coffee with milk. Here we have coffee preparation algorithm involving choice. Algorithm to prepare a cup of coffee with a choice of black coffee or coffee with milk. Step 1, start. Step 2, get the ingredients water, milk, sugar and coffee powder. Step 3, get the choice of the user, say choice, whether he wants black coffee or coffee with milk. Step 4, boil the water, add coffee powder and sugar and stir well. Step 5, if choice is coffee with milk, then add milk, stir well and go to step 6. Otherwise, go to step 6. Step 6, pour into cup. Step 7, a cup of coffee is ready to drink. Step 8, stop. Decision statements are used when the outcome of the process depends on some condition. Let us see another computational example. For example, if x is greater than y, then say x is greater than y, or else say y is greater than x. Can you predict the general form of the if construct? Make a try. Well, it is if condition then process. If condition then process 1, else process 2. Here the condition refers to any statement that may evaluate either a true value or a false value. In the discussed example, what can we conclude? Yes, the variable x can either be greater or lesser than the variable y. It cannot be both true and false. This means that if the condition is true, then a set of statements are executed. A decision making statements can also be stated in the following manner. Yeah, it is absolutely if else construct. From the construct, what do you infer? Well, if the condition is true, then process 1 is executed, else process 2 is executed. Now, you are going to try an algorithm to find maximum of 2 numbers. What will be the input? Yes, the input is the 2 given number. Then the output is the biggest among the 2 numbers. Algorithm for it goes like. Here we have algorithm to find greatest of 2 numbers. Step 1, start. Step 2, input first number as A. Step 3, input second number as B. Step 4, if A is greater than B, then print A is greater. Step 5, if A is less than B, then print B is greater. Step 6, if A is equal to B, then print A is equal to B. Step 7, stop. Here is the decision control structure. What is next? The last control structure is, yes, it is repetition. Let us have a look into it. Get up early in the morning, having breakfast, going to the school, listening to the class, coming back to home, completing the homework, sleeping. This routine continues until we finish our school. Make a guess over here. What can be a repetition? Absolutely, repetition involves executing one or more steps for a number of times. The loop executes one or more step until the condition becomes false. Think over here, in coffee preparation, where do we deploy repetition? Yes, if sugar in the coffee is not enough, you add the sugar again and taste it. If the added sugar is not enough, then you add it again. Here comes your repetition. See algorithm for this case. Here again we have a coffee preparation algorithm involving repetition. So, the algorithm is to prepare a cup of coffee with enough sweetness. Step 1, start. Step 2, get the ingredients such as water, milk, sugar and coffee powder. Step 3, boil the water, add coffee powder, sugar and milk and stir well. Step 4, taste the coffee. Step 5, if sweetness is not enough, add sugar and stir well and go to step 4. Otherwise, go to step 6. Step 6, pour into cup. Step 7, a cup of coffee is ready to drink. Step 8, stop. Next, we are going to make an attempt to write an algorithm using repetition. For example, algorithm to calculate cutoff marks in an entrance examination for n students. If it is for one student, we will be using sequential control. Think over here. For n students, then we have to deploy repetition. What you can see on the screen is an algorithm to find cutoff mark for n students. Step 1, start. Step 2, read the number of students. Step 3, initialize count to 1. Step 4, if count is less than or equal to n, read maths, physics and chemistry marks of a student. Otherwise, go to step 9. Step 5, calculate cutoff by dividing maths mark by 2, physics and chemistry marks by 4 and adding them. That is cutoff equal to maths by 2 plus physics by 4 plus chemistry by 4. Step 6, increment count by 1. Display cutoff. Step 8, go to step 4, Step 9, stop. So, here what you are seeing is a real example for swapping. Suppose in the algorithm, can you tell the purpose of using the variable count? It is used to keep track of the number of times the looping statements have been executed so far, and to stop the execution of the looping statements once it reaches the limit, that is n in this example. Wow! We have learned how to write an algorithm for the computational problem. Let us try out some examples. First, let us write an algorithm for interchanging of two values. Before getting into this problem, let us take a real life example. We have a real life problem for swapping. Suppose you are asked to exchange sugar and salt kept in two containers. The condition is that the container which had sugar earlier should consist of salt, and the container which had salt should consist of sugar. An empty container may be used for this purpose. Solution to the problem is, consider there are three containers, namely container 1, container 2 and temp containers. Suppose container 1 consists of sugar and container 2 consists of salt, as you are seeing. Fill the temp container with sugar in container 1. Now, the temp container consists of sugar and container 1 becomes empty. Then fill container 1 with salt in container 2. Now, the container 2 becomes empty, as you are seeing. Fill container 2 with sugar in temp. Now, let us go back to the problem of exchanging the values of two variables. Here, the input values are the initial values of A and B. The output is the value of A is B and the value of B is A. Let me explain in detail with an example. So, here is the problem of swapping values of two variables. Problem is, given two variables first and second, swap the values assigned to them. Consider the variable first and second which are assigned with some values. Before swapping, the variable first contains 100 and second contains 500. The objective is to replace the contents of first to 100 and the contents of second with 100, as you are seeing on the screen. After swapping, first and second should contain exchanged value. Then how to swap? That is, the value of first after swapping will be the value of second before swapping. The value of second after swapping will be the value of first before swapping. To retain the value 100, that is the value of first before swapping, we need to use a temporary variable temp and copy the value of first into the temp before executing step 1. The steps are shown in temp is equal to first, first is equal to second. After the execution, temp will be 100, first will be 500 and second will be 100. To store the correct value of second, we need the following statement: second is equal to temp. Now, after the execution of this step, temp will be 100, first will be 500 and second will be 100. So, here you are watching an algorithm for swapping. So, step 1 start, step 2 read two numbers, say first and second, step 3 move the value of first to temp, step 4 move the value of second to first, step 5 move the value of temp to second, step 6 display the value of first and second, step 7 stop. So, what you are seeing is an example how this swapping is done. So, we have a look into how the algorithm is executed. Step 1, start. Step 2, first is equal to 4, second is equal to 5. Step 3, temp is equal to 4. Here we introduce third variable, which is called temporary variable. Step 4, first is equal to 5. Now, the value of B is assigned to A. Step 5, second is equal to 4. Now, the value of temp is assigned to B. Step 6, print the values of first and second. Step 7, end. Now, we are going to try out some more examples. Have a try. Let us write an algorithm to find greatest of 3 numbers. The input is to get 3 numbers, say A, B and C, and the output is the greatest among A, B and C. Now, shall we start writing the algorithm? The solution would be, now what you are seeing is an algorithm for finding greatest of 3 numbers. Step 1, start. Step 2, read the numbers, say A, B and C. Step 3, check whether A is greater than B and C. If so, display A is the biggest number and go to step 6, that is stop. Step 4, otherwise check whether B is greater than C. If so, display B is the biggest number, then go to step 6, that is again stop. Step 5, otherwise display C is the biggest number, then step 6, stop. What would be the first step? Exactly, get the first number from the user. Subsequently, get second and third number from the user. Next, check A is greater than both B and C. Think how you could write this in algorithm. Yes, look into the screen. If this condition is true, then A is the biggest number. If this is not true, what would be the next step? B may be the biggest number. So, check for that. If B is greater than A and C, then B is the biggest number. Even if this is not true, obviously C is the biggest number among the 3 inputs. So, please watch an algorithm which finds the sum of all the numbers till -1 is entered. Step 1, start. Step 2, initialize sum to 0. I already told why should we initialize sum to 0. Step 3, get the value of A, which is the first number to be added. Step 4, if A is equal to -1, go to step 7. So, here we have to add till we enter -1. Step 5, add A to sum, that is sum is equal to sum plus A. Step 6, go to step 3 to get the next value for A. Step 7, display sum, and step 8, stop. Yeah, nice. By now, you would have got an idea about writing an algorithm. Try out the next. Write an algorithm to compute the sum of all numbers till -1 is entered. Predict the input and what would be the output. Now, try on your own. Next algorithm, what you are noticing on the screen is the largest number in a list of n number. We already saw how to find maximum among 2 and maximum among 3. This is an example for repetitive structure. Step 1, start. Step 2, read the number of elements among which maximum is to be found out, say n. Step 3, initialize count to 1. Read the first number and consider it as the biggest. Step 5, if count is less than or equal to n, read the next number, otherwise go to step 9 where you display the biggest number. If not, step 6, if the number is greater than the biggest, then assign number to the biggest. Step 7, increment the count by 1. Then step 8, go back to step 5. Step 9, display the biggest number among the number. Finally, step 10, which is stop. At last, write an algorithm to find the largest number in a list of n numbers. So, to summarize, the computational problem will be given and an algorithm, that is the sequence of instruction to solve the problem, should be written and it should be implemented on a computer program. Hope this module would have introduced to you the art of writing algorithms. Thank you. Let us meet in the next module.